Hello and welcome to Chapter 3, Security Architecture of Systems in ISO L 536, Security Architecture and Design. So Chapter 3 focuses on, as the title implies, security architecture of systems. So we're going to go through the points you see on the screen of basically why is it important, uh, the security in architecture, diagrams, and so on. This is a large topic. We're going to briefly cover it here, but it is something that you could spend an entire semester talking about. Moving on. So why is enterprise architecture important? And the short answer is that if things are built well, they are also oftentimes more secure. If you have something that is poorly designed, then it may have vulnerabilities inside of it that are difficult to detect and difficult to fix. The better something is built, and to some extent, the simpler that it is built, the better, because that's where you need this whole concept of an enterprise architecture. When we talk about enterprise, we're talking about generally things which touch the entire organization. They're systems which are valuable, that are important, and that impact the organization in a practical and real way. For example, a payroll system inside of an organization is an enterprise system because it is really important. That means that system should also have an architecture that's associated with it that is secure, well built, well developed, and so on. So the term enterprise architecture can be used kind of in multiple ways, one of which is that systems which are at an enterprise level. The other is architectures and designs which are at the entire level of the organization, and also with an expectation of a certain degree of quality and other characteristics, thoroughness, thoughtfulness of design, and built-in security. That's an important aspect as well. So moving on, security and architecture. So basically, an assessor, somebody that is looking at it, they're usually somebody that is a security architect, will come in and basically take a look at a given system. In order to do so, they've got to be proficient in things like architecture so that they can understand how the things are flowing together. In addition, they've got to know about security. So they need to know about some specialized knowledge in the realm of security assessment, as well as things like best practices and how things really should be done. And then they also need the business of the ability to capture that information and represent it in some way that is understandable by others, and then making guidance, offering guidance and suggestions for so that things can be improved or deficiencies remedied. So continuing that thought, the idea of what categorizes architectures can be done in kind of several different layers. A conceptual layer, this is something that is close to the business definitions, kind of business processes, enterprise standards. It's kind of how you think about something. A logical layer is something that is typically related to a reference architecture translated into a conceptual design. So it's like a layer above or abstracted beyond the conceptual layer. And then the physical layer is how it's actually being implemented, the actual devices and so on that might actually really be put into place. So when we do diagrams of security, something like this is a really simple version of it. Of you've got somebody out here on a computer going through a firewall, accessing a server, and that server, for whatever reason, is going to what looks like an old mainframe. But the basic idea here, though, is that you're showing connectivity between various elements of the system, with components in between that are doing certain types of function that have an expectation. So it shows you something, right? It shows you the interaction between them. But it's also at a very high level, and there's at least three different sort of things involved, potentially four if you consider that to be a network. And the firewall is obviously the brick. And the reason the name firewall, because maybe you don't know, is that in certain types of construction, a firewall is a wall that is built to withstand a fire. So in the case of like an apartment or potentially in some sort of townhouse type architectures where you have houses connected to each other, you oftentimes want a firewall between them to protect one structure from the other. It's typically something that's built out of bricks or stone or masonry, something that doesn't burn very easily. So hence the term firewall. It's come to be pretty much replaced with that concept of it's a security mechanism that is used to restrict access to from one sort of network to another, basically. Um, and so there's some sort of security controls between the user and the middle server. So there's something going on here is what we can kind of tell. And the double-headed arrow, we don't know which component calls which, who's doing what. Most likely, in the case of, assuming this is a web browser, then it's going this way. The computer is calling into the server, but we don't know that for sure because of this diagram, because it is very vague. But it does give you some sense of the components of the system, but not your very your best security design or security diagram. So, continuing that same sort of thought, this one's a little better, right? We have this concept of a warehouse. We have sources. We would assume those are data sources. We have some sort of application out here that's accessing the data that's inside of the warehouse, and it has some characteristics around analytics, charts, manipulation, intelligence, and dashboard, and so on. And then there's some sort of what is being loosely referred to as an engine that apparently is doing a certain amount of computation. So this is some form of an application platform, uh, and the operating system seems to call these things that are being termed applications. But we don't really know what that means. So whether the application in this diagram is actually something that's independent, or if it's something that is kind of a unified sort of thing, and these are logical separations of things. For example, analytics and charts, how do those differ would be a question you would probably be asking. So the challenge you face is you want to make something that's simple enough that people can understand, but yet it needs to be just kind of descriptive enough that it's clear what the diagram is trying to communicate. Um, a little better here, right? Because we can tell, okay, this is an external user talking over a particular protocol. Now we know that it's HTTPS or HTTP and HTTPS going through the internet in through something. There's probably actually a firewall in there somewhere, right? But it's not shown here. Although I guess, oh yeah, it is here because it's pointing out to that. So there's a firewall here and a firewall here and a firewall here. And the SQL servers are someplace not accessible by anything else. And so this is definitely a lot better, right? Because this is showing how HTTP traffic can be processed only by the internal resources, and um, it's not something that's being exposed out to the world. These web servers aren't sitting on the other side of that firewall to where they can be attacked on various ports and so on, other than the two that it's expecting to serve. Also, it's another good practice to have a firewall between your web server and your application server, and also between your application server and your database server. Oftentimes, your database servers historically were actually segregated out into their own network and very inaccessible. And that's basically what this is essentially trying to say. And this is actually telling you this whole thing out here is considered a DMZ, but it's an interesting definition of a DMZ because it's implying there's a firewall there. So it's a little maybe counterintuitive, but it's basically trying to communicate that this stuff down inside of the databases is internal and more secured. So a security architecture has a requirement that it needs to be um, a bit more abstract and different than other architectures. So we'll see more about that later on. But the basic idea that it needs to do is things like um, talk about things like active threat agents, infrastructure security capabilities, expected deployment models, and so on. So diagramming for security analysis, uh, This is yet another sort of diagram showing pretty much kind of the same stuff, right? You've got a web server out here or a laptop out here, most likely going over the internet through HTTP, though that's not really drawn out here. Uh, but it's probably implied because this is a web server. That would have probably been a good thing to tell what the protocols are. It also is showing you a greater detail of what the application server is. So it's a Java application server, so we know more details now. That lets us know things about what vulnerabilities might exist inside of a Java application server. Also, we have here that there's some static content that's being retrieved off of a disk or something that's being served by the web server as well. And then lastly, you've got a series of databases out here attached to a database server. So again, greater granularity, greater detail. Uh, we don't necessarily know what protocols are being used between certainly the web server and the application server. You don't know if that's going on through ODBC or JDBC or what kind of connections is being done here. But you do have some sense of the details. But as always, probably we're going to want a little bit more, or at least a narrative that's describing it. Maybe it's not necessarily in your diagram. So figure 3.5 over here is a different type of architecture compared to a web application. This is a simplistic sort of thing. There's a UI and a kernel driver. There's probably going to be some other stuff involved in most applications, but we'll leave it for that for now. Kernel level stuff is it's necessary oftentimes, and you'll read more about that in your text, but it also brings with it a certain amount of vulnerabilities because it's running at essentially elevated permissions, but you do need it to access certain types of devices and so on. Your UI doesn't need to have kernel level permissions because all it's basically doing is talking to the screen. But this is one sort of kind of simplistic architecture of showing you the UI from the higher privileged system in a classic architecture. And this does happen from time to time. It's still around. There was a time that you had to do a fair amount of stuff with kernel level stuff and drivers. There's been more layers of abstraction inside of Windows so that's less needed for a typical Windows environment anyway. So a pattern is an important concept. Patterns are a common and repeating, basically, idea. They use the word idiom, but it's basically it's a thing that you see that has a certain characteristic and shape, similar to maybe like a recipe, if you think of it that way. But you recognize them over time. And the reason they're valuable is because when you recognize the pattern, you can oftentimes have a solution that's associated to that pattern without any additional real work. So the list here is several kind of common patterns that show up. Service-oriented architecture is a good example of a very common pattern, as is the model view controller. And there's a lot more of these. There's a ton of patterns. But whenever you start identifying patterns, you can start then talking about the problems those patterns might have, as well as potential solutions. So in general, whenever you're looking at patterns, um, depending on even architecture or security, either one, you kind of need to know what the actual architecture is, and you need some representation. So probably some sort of documentation, graphs, or so on, a diagram showing you what it is, so that you can actually kind of tell what it is. There's lots of different ways that architecture can be represented. It could be written in paragraph. That's a really painful way to both describe and to understand, but it's oftentimes with some good diagrams that can help, or a combination of diagrams and text. Uh, but it's important to have that so that you have some chance of figuring out kind of what it is. Data flow diagrams show how things move from layer to layer, and they usually are directional. So you have an arrow going here that says this is going from the presentation layer down to some sort of integration layer. That's an interesting way to draw it. It may not necessarily be right, but basically what this is showing is that there's some sort of an integration layer tying all these pieces together, including the data stores and so on. Um, it It's drawn, like it says here, it looks like a bus technology, but some of it doesn't necessarily make a ton of sense as a bus technology, but that's what this diagram is implying and it making you think that it's definitely related to bus architectures. Bus is, you'll probably hear things like service-oriented architecture, message queues, and so on. That's a way of communicating in a configuration-driven sort of approach rather than point-to-point integrations. It's a preferred way of doing things most of the time. This is a little interesting, so it may just be for example. Moving on to interchange, additional interchange flows, additional data flow diagrams. This is a bit better because it actually shows you a conceptual view, but it lets you get some idea of how things are talking to each other, where things are going. You're not necessarily seeing the data flow, but you see, okay, there's some cloud services out here, there's the internet, you got some sort of access control restricting it. You've also got access control here. That's probably some sort of firewall. Um, got a message bus that this is indicating that it goes through the firewall and is available to external things. That probably means that you can either send in or receive from the service bus uh, messages from the outside of the firewall, which is or certainly outside of this private network to an external network into some sort of DMZ sort of thing. So that's it's a pretty interesting sort of thing, and it's definitely a better diagram. Doesn't necessarily give you all of the information you'd really like to see. The There's only so many things you can understand. That's the basic idea. Um, and so you don't know everything about every domain, but you may know a lot about a lot of domains. And there's a reason that you'll usually depend upon others uh, uh, to help. And also, security architects are good at security systems. Enterprise architects may be good at security, they may not. Uh, and security is oftentimes cross-domain. A security expert may be across the entire organization, not focused in on one particular department or in one particular domain. So it's a different set of skills, specialization in a particular area. So presentations have been split from external integrations, as integrations are cited in specific area, extranet. So it is typical of an enterprise to do such things. You'll also have some sort of point-to-point integration. Lease lines, not so much anymore. There was a time lease lines were really the thing. Even VPN is somewhat fading now, although it's still around. A lot of organizations are going to a more secure transfer over the internet, frankly, without necessarily in doing some sort of tunneling protocol like VPN. Uh, and the e-commerce has definitely become a bigger thing as well, so that uh, you're going to be segmenting your networks to do what's appropriate, depending upon the need at a given level. One key thing, interesting may not be a good thing. Whenever you see something that's architecturally interesting, that may tell you that it's something that may need some additional investigation. So, uh, yeah, the when you're assessing something, if you're left with a lot of questions, then it probably needs some more information. Uh, it's the details. It has to be at the right level of documentation, being at the right level, regardless of who the consumer is. So if your eyes are glazing over whenever you're looking at the detail, it probably needs to go up to where you're going not into so much detail, but yet it needs to be deep enough that it answers the question. So it's a balancing act between how deep you go into the architecture and the discussion versus making it consumable. It's going to depend as the producers of the documentation on who your audience is going to be, but you may even actually want to do a multi-layered approach to your documentation so that you have a high level abstract that maybe the executives can understand. You go down a level in the level of granularity. Maybe that's something where the I don't know, the directors are such that can understand of how things work, and then you may actually go down to that third level that's at either an architect level or a security expert level as well. So this is a good guidance that the architecture diagram needs to represent the appropriate logical components. Logical components is dependent upon lots of things: deployment model, infrastructure, and attack method. So what it is depends upon those things and what you're looking for. The Whenever you're trying to understand the architecture of a system, the key thing you're trying to figure out is um, pretty much where are the attack surfaces, what components can be treated atomic, so what ones of them essentially stand alone, and how deep should the analysis be decomposed in the architecture. So how much detail do you need to go in? How far do you need to drill into each one of the components and subcomponents and so on? And there's a point where you'll get to meaningless detail that's going to confuse the picture, but yet you may be, as in some of these early diagrams we saw in this chapter, they're way too vague. They don't share anything. Uh, so whenever you're talking about um, the type of, this is talking about an antivirus engine running inside of a separate process space, which is going to be typical. It receives commands from a UI and it talks to a driver. Um, yeah, right. So this isn't necessarily all that unique because you want your engine running at a elevated level of permission, meaning it does things that other processes may not be allowed to do. Perhaps it can write to certain folders or read certain files that normally you wouldn't want a typical process to be doing. So you want your UI to have less permissions than the lower level components. Um, so the key takeaway here is down in this where we're talking about making sure that you know who's talking to you from the point of the driver's perspective, because if something other than the AV engine were to try to talk to the driver, it's going to be a problem. So binary signatures are one way that you can do that. Essentially, it's almost like an authentication piece where the the driver needs to make sure that who it's talking to is who it's supposed to be talking to, and one way to do that is through digital signatures. So when we're talking about applying principles and patterns to certain designs, you're going to hear things like best practices and patterns. So generally speaking, the art of architecture, and that's a key word, art, it's about kind of pattern recognition to a large extent. You're looking at it, you recognize things, you see them in an abstract way to where you can convert something from one thing into something that's like it, but slightly different, but yet close enough that it'll work. And then there's lots of unique considerations and constraints that are going to figure into it. So it's one of those skills that gets better the more you do. Uh, and the, you basically try to see if it's going to fit, so to speak. It's almost like, well, this looks like a square peg. Will it go into this other hole? Oh no, it's not quite that. So you need to switch to maybe the star-shaped peg instead of the square one. Similar sort of concept. You basically go through and see if it is what it looks like and if it's close enough to actually do it. And if it does, then you can start relying on the learnings of that pattern that you've previously experienced. So you do have some principles, but it's not just principles. So defense in depth, very common. You're going to hear that in pretty much every security course you take. Positive security model. So basically, if it fails, then you don't get in. Uh, so it's a fail-safe defaults, and it minimizes the attack surface. Fail security, run with the least privilege that you can get by with. don't think that security by obscurity is actually secure, because it's not. Keep it simple, but no, only as complex as necessary to meet the requirements. You do want to catch when something has gotten in that shouldn't. Don't trust infrastructure, and this is a problem that has been around for quite a while. Whenever we moved to the cloud from on-premise solutions, this was what the problem was, is that organizations were trusting infrastructure versus enforcing their own sort of security at a component level. Same thing with don't trust services, same sort of concept, and make sure you have security defaults. So principles are important, but it's not just about principles. And with that, we can wrap up chapter 3. Uh, it is about architectural patterns, and relying or related to architectural patterns is security solutions and security patterns. So it's pretty interesting stuff, pretty useful stuff. As always, if you have any questions, do let me know. Stay safe, and I'll talk with you next week.